All right, lesson 513, we want to talk about lines of symmetry. A line of symmetry is a line separating a figure into two halves that are mirror images of each other. Line of symmetry exists for a figure for every point P. On one side of the line, there's a corresponding point Q, where L is the perpendicular bisector of P and Q. So as you can see in the picture here, the dotted line right here, this dotted line cuts PQ in half, right, at point R. So that's a line that you could reflect. If you reflected P over line R, or line L, you would get it would fall on top of Q, right? So that's the idea. We're not going to do a ton with line symmetry. We just want to make sure we understand what it is. So there's something we'll talk about with regular polygons. Okay, the word regular polygon. Okay, that means has all the sides are the same length and all the angles are the same measurement. Okay, so think like a square. That's an example of a regular polygon. A rectangle would not be because the side lengths are not all the same. Okay. All right. So speaking of squares, squares are regular polygons, and what that means is they have because there's four sides and four equal angles. That means there's four lines of symmetry, right? The lines of symmetry are shown in the picture here, and the ways that we could map this onto itself. In other words, how could I change this so that this shape ends up exactly back where it started, right? You could reflect over the line AC. You could reflect over the line BD. You could reflect over the horizontal line through the middle or vertical line through the middle. Okay. You could also do 90-degree rotations, and it would end up exactly where it started. You could do any multiple of 90, right? Because 360 would be a full spin. You can do quarter spins basically in either direction, clockwise or counterclockwise. All right. If you look at a rectangle, that's not the case. You still have two lines of symmetry, right? You have this line here and this line here. You flip it, okay, over either one of those lines, but you couldn't rotate it. The 90-degree rotation doesn't work because it doesn't map exactly onto where it was previously. 180-degree rotation, however, would work. Okay, so you just have to take a look at each shape individually and kind of decide what works and what doesn't. Now, let's scroll on down. If a rectangle is reflected through its horizontal and vertical lines of symmetry, the image is projected onto its pre-image. Okay, so that's kind of what we were just talking about. If you do a horizontal reflection, it changes. And notice the way that they write this little prime symbol, this little tick mark behind the A, that's what's changing, right? All right, so a trapezoid, if it's an isosceles trapezoid, then it can be reflected left and right, okay? Isosceles meaning that AD and BC, those two things are congruent, okay? If it is not isosceles, like JKLM down here, then there is no line of symmetry, okay? With a parallelogram, these are just some special figures, guys, that we're focused on. Then we'll look at some examples. There's no line of symmetry for a parallelogram. It doesn't work if you flip it. However, if you do a 180-degree, and remember with a parallelogram, so these two are parallel, and these two are parallel. And since they're both parallel, two sets of parallel sides, they have to also be congruent. Otherwise, it wouldn't work. So 180-degree rotation there will indeed map back onto its original self. So that's the only way you can do that. All right. So pay attention to those. We're going to talk a little bit more about regular polygons, and we'll talk about how to do that. So here's a regular polygon. This is a regular pentagon. First, draw the pentagon and label the vertices. Note the line of symmetry from A to DC, right? So the vertical line that cuts DC in half, right, makes two 90-degree angles, okay? That is a line of symmetry, okay? Now, where would there be other lines of symmetry? Since this is a regular pentagon, that means that all these angles are exactly the same, right? This angle, this angle, this angle, this angle, and this angle. And all of these sides are also equal. So we also have one here right there, and here. So we have five lines of symmetry, okay? We also can rotate this so that A goes to B, B goes to C, C goes to D, right? So we have five lines of symmetry. No, pins are. Okay, symmetry. And then we also need to talk about how we can rotate it. So if there's 360 degrees for a full rotation, right, and there's 5 points of rotation because it's regular, then we can do 360 divided by 5, and what you get is that is going to be 72, okay? So every multiple of 72 will give you a rotation. So 72, 144, so on and so forth. Next will be 216, and you keep going all the way up to 360. Okay, all of those degrees of rotation would work. So that's that. Okay, now piece of rectangular paper is folded in such a way. So what do we know? All right, so here's the trick. So I know that this is 61. I know that this is 90. Okay, because it was a rectangle, right? So 61 and 90 is 151, and take that away from 180 means that this down here is 29. Now the trick is this alpha symbol right here. It was folded over this line, right? Which means that this angle here and this angle here have to be the same thing because it's the same width of paper, right, when it's folded. So that means that this is also 29. And since this down here was originally a 90-degree angle, then that means we can figure out beta here by doing 90 minus 29 minus 29. Okay? So when you do that, it makes it a little bit easier problem, right? You gotta start working piece by piece to see what it is you're looking for. So 90 minus 29 is 32 degrees. Okay? All right, and then from there we're going to go and look at the next one. And this last one, it says, given the quadrilateral ABCE, the square ABCD, and the information that F is the same distance from A and C, so that tells you that this is congruent, and we know that this right here is congruent. Show that ABC is symmetrical along BE, right? So the trick here is this. Since all of these are the same length, right, since this is a square, okay, and BF is going to be a bisector of AC, that means that this is also a bisector. And since that's a straight line that's continued, what that tells you is that these two have to also be congruent because this goes down to the point E, okay? So it's just putting all the pieces together here and just showing that things are congruent is what you're trying to do here. Because we're given that this is a square, that's how you would show that these are symmetrical, okay? So triangle, there's a lot of other things we can say though, but basically we want to finally say that triangle AFE is congruent to triangle CFE, right? And therefore, we can say that BE is a line of symmetry.